Hello everyone. Today we are going to talk about two very important reactions which are there in your NEET curriculum definitely. Okay, so the reactions are basically your Bayer-Villiger oxidation and the Beckmann rearrangement. Now you may ask that, sir, why you have chosen these two reactions together? Because these two reactions is something that where your starting material is same, but the products you get that is different. But that two different products which you obtain, that product also has a same analogy. Let's see what actually happens. You first start with a ketone. Now this ketone, you use a proper reagents. Okay, now in one case we use any par acid. Let's say MCPBA we can use, or we can use your perbenzoic acid also we can use, right? So we can use MCPBA as a very common reagent, MCPBA, that is called metachloroperbenzoic acid. Formula, let me write the structure here: meta position chlorine and perbenzoic acid. Okay, this is your MCPBA, metachloroperbenzoic acid. And beta, if I write a product here, the product which I will getting RC double bonded O, OR. Let's say I'm taking R prime, so this is my R prime. Okay, so basically the thing is that this is the ketone which is converting into a corresponding ester molecule. And here in case of beta Beckmann rearrangement, if I write the reagent, first we treat with NH2OH, that is hydroxylamine, and then in the second case we treat with your H+. Now in this case what happens, this one actually will convert and this will give you the product, that's it, your R C double bonded O in H R prime. So this is called your, this is your basically an amide. This is basically an amide molecule. Okay, and here beta, this is my an ester moiety. Okay, this reaction is called my Bayer-Villiger oxidation. This formation of the ester molecule is called the Bayer-Villiger oxidation reaction, and beta in this case the formation of the amide is called known as the Beckmann rearrangement. Now next two couple of slides followed by 2 MCQs, we are going to talk about the reaction mechanism, how this of this particular reaction. And you should watch this video till the end, so that don't worry that everything you will be understand completely for this part of the reactions. Okay, so don't worry, it's very simple reaction and it's very simple mechanism. Okay, chalo, let's move. Now in the first case, if I see that the thing is that R C double bonded O R, correct? Now this molecule we are treating with any par acid, let's say PHCO3H, okay, or let's say we are using MCPBA. Okay, we are using MCPBA, okay, metachloroperbenzoic acid. Now whatever the part is, in the every perbenzoic acid contains a part like this, contains a part. This is your acid part and this is this dioxy part, okay, which actually the par acid. Okay, like see if I talk about hydrogen peroxide, in hydrogen peroxide if you see this moiety is there, so this is basically peroxo moiety. Now in this peroxo moiety, remember the interacting oxygen atom, is basically beta this one is your interacting oxygen atom, and this oxygen atom actually reacts with this par acid, reacts with this ketone and forms a different compound. जो देखते हैं वो कैसा compound form होता है. Okay, now see in acid medium, definitely it's beta in acid medium what happens, this lone pair will be first protonated. Okay, so beta the what will be the product here, देखो देखते हैं बेटा, R C double bonded OH plus, okay, R, okay, और यहाँ पे क्या है मेरा, यहाँ पे जो पार एसिड का जो ऑक्सीजन है, this one actually attacks here and releases the OH. So what is the next product it is from? देखते हैं. Next thing is what? R C OH R prime, okay, R prime, यहाँ पे H है, यहाँ पे H है, R prime, okay, O whatever moiety is here, correct. Next step, what happens actually? Now next step बहुत ही interesting होता है. Now in the next step, one thing that while this OH is turning back here, this R actually, any one of the R, which R has a higher migrating aptitude. Migrating aptitude is what? The tendency to migrate. The group which has higher tendency to migrate. I will put a separate video on this migratory aptitude for the different ionization reaction, where I will tell you the complete that how it actually works. Okay, for the time being, just trust me and think that, let's say I'm assuming that R prime group has a higher migrating aptitude. Okay, I'm writing here it has a higher migrating aptitude, meaning higher tendency to migrate from one place to another place. So if this one goes back here, this R prime migrates here, and beta this one turns out. So what is the final product we are getting here? The final product which we are getting here is R C double bonded O, and you can see this R is now shifted to the oxygen, so OR prime plus your whatever moiety is here, we are getting the corresponding acid. Okay, and definitely since the medium is acid medium, so this will not stay as oxygen, it will be OH. That means what is the product? Now the acid, the par acid after the reaction is now converted into a normal acid, right? And the corresponding, our ketone has now converted into a corresponding ester molecule. Okay, so this is what is all about your Bayer-Villiger oxidation reaction. And since oxygen is added here, so this reaction is nothing but your beta oxidation reaction. This beta reaction is nothing but your oxidation reaction. Okay, very simple and short method. Now let's talk about the Beckmann rearrangement and the importance of the Beckmann rearrangement. Remember one thing, in case of Beckmann rearrangement, what we are doing, we are basically here, we always start with this molecule. Now beta, if I treat this molecule with NH2OH, that is hydroxylamine, simply it will be directly converted to the corresponding oxime. So what it forms? R prime C double bonded in OH, right? So this is what? This is nothing but your corresponding oxime. Okay, now this oxime is very reactive, but the point is that this oxime reacts only in acidic medium. So if I give an acid here, what this will do? This will capture like this. And double bonded N. So there will be a formation of a water molecule here. Now water, we know water is a very good living group. Okay, so what actually happens here? Now after this step, actually this R prime, as I said also earlier, that the R prime has a higher your migratory aptitude. So this R prime, what it will do? It will directly attack the N and the oxygen water will come out. Okay, so beta, what is my product here we are getting from this next step? We are getting R C, यहाँ पे we will put a plus here, double bonded N R prime. Okay, now beta, there is a water in the medium, right? There will be a water in the medium. So what this water will be doing? This water will be attacking here, and what we will getting? So water H will come out, and finally what we are getting here? R C OH double bond N R prime, right? So since we are getting a acid molecule back and we are putting a water molecule back, then here the role of acid, remember beta, the role of acid is as a catalyst. Okay, the role of acid is as a catalyst. So what we will do, this will tautomerize and it will form RCOH NH R prime, right? So basically what we are getting here finally we are getting our corresponding amide back. So this is all about your Beckmann rearrangement reaction. Okay beta, very simple, very अच्छा और एक MCQs देख लेते हैं थोड़ा. The question is predict the product. Okay, predict the product. Now you know that sir, ये तो बहुत ही simple वाला है, बहुत ही simple है. The product will be like this sir. The product will be like this. Sir यहाँ पे in this in between there will be an oxygen and double bonded O CH3. But beta, my question is like that ये जो bond है, this bond is above the plane. Now will it be like this, माने above the plane will be, or it will stay as below the plane? If you see the mechanism very clearly here, if you see, when after this addition in the ketone here, this R group is getting attached, is attacking from the back side here. Okay, and this is the planar one. Okay, this is the planar moiety here. Now after this R group is attacking, this one is the backside attack. This is a backside attack. Okay, this is the backside attack. The backside attack. Okay, now since it is a backside attack, if the bond was above the plane, it will directly go to the below the plane, right? So if I use that logic, then यहाँ पे क्या होगा मेरा बेटा, यहाँ पे will be a dotted bond. Okay, so this will be your corresponding product. But the main thing is that when we add this per acid, this will be converted into a ketone, and this ketone will be your below the plane ketone. It will be a below the plane ketone. Okay, and last और एक example देखते हैं यहाँ पे for this one. It's a very simple. सर ये तो बहुत ही simple है, क्या questions दे रहे हो, right? अच्छा चलो product लिखते हैं. First definitely it will be, if I add one, first it will be double bonded NOH. Double bonded NOH, oxime will be creating. Now H plus if you give, definitely your H plus if you give, there will be a ring will expand, because this will come here, then water will come out like that, the steps will be good. So instead of that, what we will be getting, something like this. This is called caprolactam. Okay, which is one of the source of nylon 6, one of the monomer of nylon 6. And definitely we are talking about here that thing that beta, if I treat this one with a base, this will be hydrolyzing from here, and what it will do, it will create a polymer of like this. And nothing but this polymer is my 5 plus 1, the total 6. So this is called nylon 6. Okay, so nylon 6 एक MCQ आया था एक बार, that in formation of nylon 6 what reaction they have used. So your answer will be Beckmann rearrangement. It's a very important MCQ for particular this year भी आ सकता है. Fine, so that's it from my side. This was all about your Bayer-Villiger oxidation and Beckmann rearrangement. Hope to like the video and definitely share with your friends. And if you have any questions or comment about this particular topic, feel free, or if you want any other topic to be discussed in this form of the video, so feel free to write in the comment section. So from my side, bye everyone, take care, see you next time.